stoichiometry and Faraday's law. We're going to learn a new constant. The amount of electrons that pass through a cell will determine the mass of the substances reacted or produced at the electrodes. So if we have a voltmeter or we have a battery, depending on whether electricity is being created from chemical energy or the electricity is creating chemical energy, the amount of electrons in the system determine how much is going to be produced or broken down. Okay? So the dude that figured it all out was Michael Faraday, and he looked at the relationship between electrical current and electrochemical change and what was happening at the anode versus what was happening at the cathode. And so what he found was the mass of an element produced or consumed is directly proportional to the current and the time. So how much current, how much electricity is going through the system, and how long. Okay? So the mass is directly proportional to the current and the time. So we can then say that the number of electrons, which is what the N stands for, it's the moles of an electron, is equal to current, which is I, T, which is time, all divided by Faraday's constant. Just like with all other chemistry formulas, you don't get this given to you. You need to remember it. Okay? The which? No, the constant is, but the formula is not. Okay, so if you look on page 3 under miscellaneous, you will see Faraday's constant listed there, but the formula itself is not there. Look on page 3. We haven't learned any formulas. This is the first formula we've had to learn. One formula so far you've had to learn. Okay? Now, because there is a constant involved, we need to make sure that we're in the right units. The constant is C per moles. So we need to make sure that our moles is in moles and not millimoles or millimoles, that our amps are in amps and not in milliamps or mega amps, and that our time is in seconds and not minutes or hours. Faraday's law goes for both voltaic and electrolytic. One takes electricity and creates chemical potential energy, and one takes chemical potential energy and creates electricity. Okay? In order for us to do Faraday's law, we have to show the electrons. And so half reactions that we've been practicing all along, oxidation half reactions and reduction half reactions, are the only place that we come up with the number of electrons. We don't do it when we're dealing with oxidation half reaction or with oxidation numbers. Even when we're trying to balance an equation with oxidation numbers and we think that we're including electrons, electrons aren't actually written into the half reaction. So oxidation and reduction half reactions are the only place where we can get electrons. So it cannot be off of the balanced reaction. You have to break it down. This is what it looks like. What is the mass of copper deposited at the cathode of a copper electrorefining cell operating at 12 amps for 40 minutes? So it says at the cathode, that's keyword. And a cathode occurs with which reaction? Which half reaction? Do we agree with Declan? Okay, so when we look at our book then, Hello. I'm one page too far. Here we go. And we find copper. Remember, this is the reduction. If we look at the top, this is the reduction half reaction. So copper 2 plus 2 electrons gives us copper solid. That's the reaction at the cathode. Lots of key words in there, right? And then our pieces of information that we have. We have current at 12.0 amps. We have time at 40.0 minutes. And we're looking for mass. Paying attention to minutes. It has to be in seconds. How do we go from minutes to seconds? Multiply by 60. There's 60 seconds in 1 minute, which is equal to, yeah, you shouldn't have needed a calculator. 4 times 6 is 24. 2 zeros after that. Okay. So how do we find mass? How do we answer that particular part of the question? So how we solve for mass is molar mass times the number of moles, right? How do we solve for the number of moles? Because it's not in our list. IT over F. I being 12.0 amps, time being 2400 seconds, and Faraday's constant, which you can find on page 3, being 9.65 times 10 to the 4 coulombs per mole. It's actually, coulombs is what? Do you remember from physics? Coulombs measures what? How about KQQ equal over R squared? Coulombs measures electrons carry a coulombs measure charge. It's an electricity piece. It's been a while since physics, but lo and behold, here we are. Okay, so my number of electrons are, or my moles of electrons are, okay, this is moles of electrons, but what do I need here? What is that moles? This is moles of copper. So I'm going to take my moles of electrons and I'm going to look at want over have. I have moles of electrons. I want moles of copper. How many electrons are there for 1 mole of copper? 2 moles of electron for every 1 mole of copper. There's an unspoken 1 here. And if I multiply 0.2984 by a half, I'm going to get what? 0.149223797. Okay, so there's 0.1492 moles of copper. Perfect. Now I can go back and I can solve for my mass, because mass is going to be equal to the molar mass of copper, which is 63.55 grams per mole. Where do you find that information? Perfect. times by 0.492. My mass is 9.0831032. Okay. Grams. When I go back to the question, how many significant digits am I looking at? 3. 1, 2, 3. So my mass is 9.48 grams. Always start with what is the question asking you to find, and then branch out to fill in all the pieces that you do have. Having been after physics makes it easier? It absolutely is formula manipulation. All right, let's look at it again. In the chlor-alkali industry, large quantities of chlorine gas are produced using an electrolytic process that is described by the following chemical reactions. 2 sodium chlorides plus 2 waters gives me 2 sodium hydroxides, chlorine gas, and hydrogen gas. If 500 grams of chlorine need to be produced in 24 hours, what is the required current? I don't know. Let's start with the information that we do have, and we'll go from there. So Declan, give me one piece of information. Okay, another piece of information. Another piece of information.
Faraday's law. Constant is 9.65 times 10 to the 4 coulombs per mole.
Coulombs per mole.
Yeah.
Another piece of information.
Coulomb is 86,400
seconds. So we took the 24 hours, multiplied it by 3,600, and we got 86,400 seconds. Okay. The other thing that we have to do is we have to figure out the half reaction. So when we do this and we figure out through oxidation numbers, chloride goes from -1 to 0. What kind of reaction is that? Okay. So when we look at that, we go from 2Cl negative to Cl2 gas. If I have 2 negative here, what do I need on this side? 2 electrons. We don't even have to open our book. We can do this quite well. Now the question is asking us, what is the required current? How do we solve for required current? Okay, Faraday's law says this. So I is going to be equal to moles of electrons times Faraday's constant divided by time. I have time, I have Faraday's constant, I don't have moles of electrons. Okay, first though, I need, I'm going to look at NE is going to be equal to the moles of, what am I looking for here? This is what I'm looking for. Current here. Of chlorine. No, chloride. Sorry. Moles of chloride. I know, but what do I want? I was right. This is chlorine gas. So I'm going to have Cl2 moles here, and I'm going to have moles of Cl here. Electrons. Electrons. So there is 1 mole of electron, right? There's an unspoken value there, and there are 2 electrons. How do I get moles of chlorine?
Molar mass divided by mass. No, mass divided by mass.
Mass divided by molar mass is going to get me my moles of Cl2. We did. Sydney already did that. The mass of chloride is 35.45 grams per mole. So Sydney already doubled it. Okay. So now I can work backwards. I've got 500 grams of Cl2 divided by 70.90 grams per mole. And I get what for a value?
70.05318617.
Now that I have moles of Cl2, I can do this piece here. I can go moles of electrons is equal to 7.0521 moles of Cl2 multiplied by 2 moles of electrons for every 1 mole of Cl2 from that's the stoichiometric part, right? Moles to moles talk. Moles of electrons then equals 14.1043 blah 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 moles. Now that I have moles of electrons, can I go and solve for my current? Yes. Does that help, Declan? Okay. No worries. What do I get for my current? So we get 15.753 because you're going to keep all your decimals all the way through. When I go back to the original question, my sig digs come down to 3. 1, 2, 3. 5 has an influence on the 7. So my current is 15.8 amps. Okay.